Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video is for the course of SMS 3123 for chapter 4, comparing two population pet difference experiment. So this is purposely for the course of non-parametric statistic. So this is the content for this chapter. We will use Wilcoxon sun rank test. There are two situations for small samples. Which we assume less than 25, and in this video I will show you step by step how to do the analysis. And number 3, large sample for n greater than 25. I'll show you the theory behind it, but for the calculation I will show you in my next video using SPSS instead of you calculate it manually. Alright, so Wilcoxon sign rank test is actually a test probability distribution of two related population. When we say related, means the data come from the same source. Okay, and in other words, we may say it's referring to that before and after data. Before and after data means we get it from the same source. Okay, if we compare this with the parametric statistic, it actually corresponds to t-test for dependent. Okay, t-test for dependent or pet t-test, where we analyze or compare means. Okay, dependent population or dependent means. That is for parametric. And for non-parametric, that I'll show you here, we use Wilcoxon sign rank test. So the assumption for this Wilcoxon sign rank test is basically we assume the data is a random samples and both population are continuous. And as I said just now, if the samples are large, which is greater than or equal to 5, basically we will use normal approximation. Okay, as usual, for Wilcoxon sign rank test, I divided into two, which is one tail test and also two tail tests. For instance, let D1 and D2 represent the probability distribution for population 1 and 2 respectively. For this case, since it is a pet sample or pet difference experiment, so D1 represents distribution for the first population, which refers to before data, and D2 represent the after data, which from the same source. Okay. So one tail test, the hypothesis, you may write down D1 and D2 are identical. This means that D1 minus D2 equal to 0. Okay, D1 and D2 are identical, or D1 minus D2 equal to 0, which also means median difference is 0. And hypothesis alternative is D1 is shifted to the right of D2. This is one tail test. Or D1 is shifted to the left of D2. Corresponding to this hypothesis, next step is you calculate the difference within each of the n-matched pairs of observations, and then we rank the absolute value of the n differences from the smallest rank, which is 1, to the highest rank n. And then we calculate the rank sum, which we notify with t minus for the negative differences, and the rank sum t plus of the positive differences. And please note that differences equal to 0 are eliminated and the number n of differences is reduced accordingly. I will explain further in the example later on. And then the test statistic, if you see here, if your hypothesis alternative D1 is shifted to the right of D2, then the test statistic is T negative or T minus. Okay, if your D1, your hypothesis alternative is D1 is shifted to the left of D2, then your test statistic is T plus. Okay, so for this case, this is your hypothesis alternative. D1 is shifted to the right of D2, which means data before, the population of data before is shifted to the right of data after. That's why your test statistic will be T minus, which represent rank sum of the negative differences. Okay, and the rejection region is we will compare the t-test statistic here with t-null. T-null refers to a critical value for Wilcoxon sign rank test, which we can find. It can be found in Wilcoxon table. You may just Google it. You will find many form of Wilcoxon table, which they have the value of alpha and also um, the number of sample, which is n, after you remove if there is a zero difference. Okay, in terms of ranking, as usual, if it is tie, so you need to take the average. Okay, for instance, you rank 2 3 4, then you need to plus 2 plus 3 plus 4 divided by 3. Take the average and give the rank to those three number with the same rank. Okay, so this is the case for two-tailed test, similar, but the only difference is the hypothesis alternative. Um, so if just now D1 and D2 identical, median is different is 0, is same as one tail. But for the hypothesis alternative, you measure here is D1 is shifted to the left or to the right. Remember just now, if it is one tail, it's either shift to the left or it's still shift to the right. Okay, but for this a two tail, it is both. In other words, you also may write down this as a median difference is not 0. Okay, so next step, similar to the one-tail test, for the two-tail test, the second step again, you need to calculate the difference within each of the n matched pairs of observation. When I said matched pairs, means that it's based on your data x1 minus x2. X1 before minus x1 after. So that's the flow. Okay, and then next step, as usual, you rank the absolute value. Okay, you rank from smallest 1 to highest n, and then again you calculate the rank sum t minus of the negative differences and t plus of the positive differences, and you eliminate if the difference equal to 0, means your n will be reduced. For two-tail test, the test statistic t, you take the minimum between t minus and t plus. If t minus, for example, is 3 and t plus is 10, that means your t test statistic is t minus. That is how you identify test statistic. And again, rejection region, again, you compare this t test statistic with t from critical value from Wilcoxon table. Okay, so this is the condition required for a valid sign rank test. The sample of differences is randomly selected from the population, and the probability distribution from which the sample of paired differences is drawn is continuous. Okay, so as a summary, so this is the sign rank test procedure. First step is when you got the question, of course, you need to identify what is your hypothesis alternative. And then you know the data already, which is small or large sample. Next step, you need to find the difference scores. D represent different, X1I represent first data from the first population, X2I represent first data from the second population. Okay, so first thing first, find the difference, and then you need to take the absolute value of the differences, means all we didn't assign a sign here, positive or negative, so we take the absolute value, and then we delete the differences with 0 value, and then we rank, begins with the smallest, rank 1, and then assign rank same sign as the I, and we need to sum the positive rank t plus and negative ranks t minus. As I said just now, is if it's one tail, it's either t minus or t plus. You compare with the t critical value from Wilcoxon table. And if there's a two-tail test, you need to take the smaller between t minus or t plus, and you compare with the critical value from Wilcoxon table. Okay, let's look at this step. How to compute or find the difference, and also how to compute the t plus and t minus. So the one that I show you here is the sign rank test computation table. As you see here, the first column here represent before or data, the first data from the first population, which normally before. And then second column represent the data after or the second population data. DI here, the third column represent the difference. Most of the time before minus after for each of the data. And the fourth column here is the absolute value for the difference. Okay. And then fifth column here, RI is the rank. Of course, you need to rank it from the smallest to highest. And then we assign a sign, either it's positive or negative. And sign R here represent the sign together with the rank. And at the bottom here, T plus represent the sum rank for positive differences, and T minus represent the sum rank for negative differences. Okay, so let's look at the example. For instance, you work in the finance department. Is the new financial system faster compared to the current system? Here, faster mean the times is faster mean the times is lower compared to before. So this is the data. We have 6 users here. Okay, if you use current system, this is the time 9.98, and if you use the new system, this is the time 9.88. So this is the time when you use current system, this is the time when you use new system. And the example here claim that the new system is faster, which means the time is lower compared to the current. So you need to test this. Okay. So the user here is the source of data. The source of data is the same, 6 sample here. And we have current system, the time for current system, and the time for new system. So how to check? First of all, you need to identify a hypothesis. Okay, so identical distribution means there's the median is 0. Okay, distribution current equal to distribution new, which also can be written as d current minus d new equal to 0. Okay, and the hypothesis alternative, d current shifted to the right mean d1, or d currents shifted to the right mean is faster compared it's faster compared to current. Okay, so this is the step how to calculate the sum rank T plus and T minus. So the same form of table, X1I here represent the first population data, which is current system, and X2I here represent the time using new system. Okay, so DI here is the difference. So first thing you need to subtract minus 9.98 minus 9.88, x1i minus x2i, so that is di. So this is the value after you find the difference, and you can see that the last data here 9.84 is the same before and after, or between the current system and the new system, so that's why the difference is 0. And then the next column, you find the absolute value, means there is no positive or negative sign. So this is the value. And RI represent rank from smallest to highest. So for this data, of course, we omit the difference 0. That's why we start with 0.01 as rank 1. And then next, we have 0.07. We have two data here, 0.07. That's why the rank is 2 and 3. So you need to take the average. 2 plus 3 is 5. 5 divided by 2 is 2.5. That's why the rank is 2.5 here and 2.5 here. Next, 0.104, 0.1955. So there's only 5 data here just because there's one data with 0 difference. So again, we assign the sign here, all this positive. Okay, and that's mean here T plus is 15. When you add this 4 5, 5, 7.5, 12.5, 12.5 plus 2.5, you got 15. How about T minus? We don't have the data here. That means T minus is equal to 0. Okay, so for this case, remember the hypothesis alternative. So your test statistic will be T minus equal to 0. So this value you need to compare with the T critical from Wilcoxon table. Alright, so we have from here as well, you can see instead of 6, one data has been eliminated. Okay, has been eliminated just because the difference is 0. So you only have 5 data, which is n equal to 5 here. Now n equal to 5, your alpha is 0.05. So next, let's look how we get the T critical from table. So this is actually just a portion of the table. You may just search or Google the Wilcoxon sign rank table and you can find many of it. The form of the table most of the time is either they stated there one tail or two tail and the n. Okay, what is the sample size? For this case, for this question, we have one tail test with alpha 0.01. So we take this row. And what is your n? N is equal to 5 after we eliminate one sample. That's because the difference is 0. So with this alpha 0.05 and n equal to 5, so your T critical is equal to 1. So remember, you got T minus just now 0. You need to compare with this T critical 1. So this is what you got. This is your hypothesis. Your n is 5. So from the table, you got T5, which is your n. 0.05 is your alpha, equal to 1. Your test statistic from your calculation just now, you got T minus equal to 0. So the decision is you need to compare your test statistic T with T critical value. For this case, since T minus, which is 0, less than T critical, which is 1, so we reject hash null. Okay, when we reject hash null, so the conclusion is there is enough evidence to say that the new system is faster compared to the current system. So that is how you do it when your sample size is small. Okay, you may find many other example for your exercise. Okay, all right. So that is for small sample. What if your data is large, which is greater than or equal to 25? So here I just show you the concept behind it, but there's no example of calculation because I want to teach you how to do it using SPSS later on. Okay, not on this video. In our next video, I will show you how to do all the analysis for non-parametric that you learn from chapter 1 until this chapter 4 using SPSS. Okay, also you can use those knowledge in your assignment, group assignment. Okay, this is for large sample and greater than 25. So similar one tail test, but the only difference here, test statistic Z. We use Z because when the data is large or sample is large, we normally use approximate normal approximation. That's why we use Z, and the rejection rate, of course, we could compare with the normal table. Okay. Okay, the same assumption for a large sample, similar to the small sample. Okay, this is for two-tail test, similar. And the only difference is the rejection region here because it's two-tailed, so we have left and right a rejection region. Okay, the test statistic is still the same. Okay. Alright, so this is the task 4. As usual, I think that is all for this video. For PET sample, for PET sample, non-parametric statistic, which if you remember in the previous course that you took, which is semester 033, you learn about the parametric test. Concurrent with this is we call it a PET test for parametric statistic. For this video, mainly for PET sample but non-parametric statistic, which is Wilcoxon sign rank test. So this is the task for question. As usual, I want you for your attendance purposes, Okay, you need to answer this task, um, and then write down your comment, write down comment and YouTube. Just comment done and give your metric number, and then also you need to answer this and upload this in the my guru platform for task 4. Okay, only to those submit within a week, then I will consider that as your attendance. So please do it and feel free to ask in our WhatsApp group for immediate response. Okay, so together with this also I'll give you another exercise. So this is for large sample, which I'm intend to show how to do it using SPSS later on after we're done with the next chapter, I think, so that you can use this knowledge to do your assignment, group assignment. Okay, so this is the task. Please do it. Feel free to ask if you have any question in regard of this topic and any other topic, and also if you have any question with the your assignment. Okay, I think that is all for today. Assalamualaikum.